Hello everyone and welcome to the second part in the cloud game development series. This is where we make a cloud Tic Tac Toe game on Scratch. In the last video we coded the game in such a way that the cat movement in one project was replicated across projects. In this video we will make that movement a lot smoother, less laggy and overall much more realistic. Of course, it goes without saying, if you are not up to speed with what we've already done so far because you have not watched part 1, then make sure you click the card up here to watch it right now. So with that out of the way, let's jump right into the program. In the final program, each cloud variable will be storing a lot of things. For example, we'll be storing the timestamp of the player's last connection, we'll be storing the board coordinates, meaning which square is controlled by each player, we'll be storing the player's username, and so on. If we were storing just numbers, then a simple approach would do. We can just add number after number. But since we're also going to be storing letters and special characters in the cloud variables, for example through the username, we are in for some problems. Cloud variables can only store numbers, not letters or special characters. Just setting the cloud variable to the player's username will result in a whole bunch of errors. So to get around this problem, we have to be a bit creative. What we can do is convert all of the letters which we intend to store to numbers. We can then store these numbers in the cloud variable, and when we're reading the data in the other project, convert it back from numbers to letters. To facilitate this process of encoding and decoding, we must first set up our own code by assigning a number to each character. This is best done through a list. So we head over to the Initializer sprite. As usual, we start with a when green flag is clicked. To ensure that the code is set up immediately, we create a block called setupCodeList and making sure to run without screen refresh. Okay, we now put that block to run right after the green flag is clicked. We still have not created our list, so let's do that right now. We can call it code and set it for all sprites. At the start, we will delete everything that is in the list because otherwise the same sequence will be repeated multiple times when the green flag is clicked. Alright, next, within a repeat 9, we add a blank to code. This is to leave the first 9 elements of the code list empty. After this, we must add each letter in the English alphabet to the list, from A to Z. This may seem quite monotonous and unneeded, but trust me when I say that this is absolutely necessary. You will be amazed later on at what setting up such a simple list allows us to accomplish. After the alphabet, we must add numbers from 0 to 9 one by one. Rather than do it the conventional way, we can take a shortcut by using a loop. For this, we create a new variable called C for this sprite only. Initially, we set C to 0 and within a repeat 10, add C to code and then change C by 1. This way, the variable C takes on every value from 0 to 9 and all of these digits are added to the list. The last things we have to add are the special characters that can be present in usernames. This includes plus, minus, full stop, space and underscore. Okay, so that was quite tedious, but I assure you that it was worth it. If you test out the program after showing the list, you should have 50 elements inside it. Now, let me explain how the encoding and decoding will happen. Let's say we want to send the name dog. Each letter of the word will be converted to its corresponding item number in the list. How exactly would this work out? Well, D becomes 13, then O would become 24. Finally, G becomes 16. Thus, dog gets encoded to 132416. This will be stored in the cloud variable, and in the other projects, we will be doing the reverse of this. We decode 2 digits at a time, so 13 becomes D, 24 becomes O, and 16 becomes G. If you're a smart person, you should also realize why we left the first 9 elements empty in the code list. Let us suppose now that instead of the letter A being at index number 10, it was at index number 1 and all of the letters that followed it were immediately after. If this was the case, dog would be encoded as 4157. So far, so good. However, there is no way to decode this because there are 2 distinct possibilities. 4157 could be dog, but it can also be DAEG. This is the reason why the number of digits representing each letter must be completely uniform. In our case, each number has 2 digits. Okay, that was an overview of the encoding and decoding concept, and let's now code those things into reality. So let's go to the player sprite and create a custom block called encode. We add a text input called value and make sure to run without screen refresh. Once the block is ready, we create a new variable called C for this sprite only. Initially, we set C to 1 and then create another variable called encoded for this sprite only. We throw in a loop and repeat this the length of value times. Within the loop, we set encoded to the joint value of encoded and item number letter C of value encode. Following this, we change C by 1 and outside of the loop, we set encoded to the joint value of encoded and 0, 0. Okay, that was quite some code, and let me now explain what each line does. First of all, what exactly is the value input going to be? Well, it is going to be whatever word or number that we wish to encode. Let's use the same example as we did earlier, which is the word dog. The length of value would equate to the number of letters in the word dog, which is 3. Thus, this loop will repeat 3 times. Let us further assume that the encoded variable is blank at the beginning. In the first run, encoded will be set to the item number of letter D in the code list. This is 13. In the second run, the encoded variable will be set to the joint value of 13 and the item number of O. This equates to 1324. Finally, in the third run, encoded is set to the joint value of 1324 and the item number of G. This equates to 132416. This is exactly what we want. Now, what exactly is the purpose of the last line of code? Why are we adding 2 zeros to the end of the string of numbers? Well, in the last video, I mentioned that the reason the cat's movement was choppy and disconnected from both axes was the fact that we were using 2 cloud variables, one for the x-axis and one for the y-axis. I also mentioned that in order to fix that bug, we had to store the x and y positions of the cat within a single cloud variable. Think about how the variable would look like if we just threw in the encoded values of the digits. Well, it would be a complete mess because there would be multiple possibilities of decoding. The y positions could be this, or they could be this, or they could even be this. What we need, therefore, is some way of distinguishing between the numbers. We need to add something that tells us when a particular attribute starts and when it ends. Thus, if we add a couple of zeros at the end, this enables us to know with certainty what the value of each attribute is. That's actually it for encoding strings. Here I have opened a second project file with the same list and function. Now you do not have to follow me here because I'm just doing this to show you that the code actually works. So I have the same example I talked about earlier. At the beginning, I set encoded to blank, and this is reflected in the encoded variable. However, once I run the custom block, the encoded variable changes into exactly what we want it to. Okay, let's now move on and start programming the next function. This will be called getCloudDataFor. Once again, we add a text input called player number and we make sure to run without screen refresh. Next, we create a variable called value for this sprite only. If the player number is 1, then we set value to P1, otherwise we set value to P2. What this custom block does should be quite obvious. We are just storing the contents of the particular cloud variable we want to manipulate inside the value variable. Okay, let's move on to the next block. This will be called begin decoding off. We add a text input called code and run without screen refresh. Within the function definition, we set encoded to code and then set C to 1. These things are necessary precursors to the decoding script, and you will soon understand why this is necessary. Alright, let's now do the main decoding script. This will be called getNextValue, and like the other custom blocks, we run without screen refresh. First, we set value to blank. We then create a variable called letterID for this sprite only. Within a forever loop, we set letterID to the joint value of letter C of encoded and letter C+1 of encoded. After this, we change C by 2. If the letterID variable is less than 1, then we stop the particular script. Outside the if-then condition, we set value to the joint resultant of value and item letterID of code. Okay, that was a lot of code, and it's time for me to explain how the decoding blocks work. So once again, I've switched to the second project to show the outputs more clearly. Like I mentioned earlier, you do not have to follow me during this part of the tutorial, and I'm doing this just to give you an idea of how the code is going to work. Let me use the encoding function to encode the words dog and cat. As you can see at the top, the cloud variable becomes this number. With the begin decoding block, the encoded variable will take on the value of P1. When the getNextValue block is run, the letterID variable first takes on the joint value of the first two letters of encoded. This would be 1, 3. At the end of the loop, the value is set to the joint resultant of itself and item letterID of code. Remember, letterID contains the index of the letter that we want to decode. So item letterID of code will become the very letter that we're trying to get. The first run of the loop will result in value becoming D. In the second run, letterID would become 24 by joining the third and fourth letter. Value will now become the joint result of D and O, which is DO. You probably see that this process will complete the entire first word. The value variable will become dog when during the fourth iteration, the letterID becomes 0, 0. In this case, the variable C increments by 2. However, the value variable does not change as the if condition preceding it kicks in. Since letterID is less than 1, the custom block's script is immediately halted. This is why the value variable stays as dog. What you can see here is that using the getNextValue function leads to us getting the decoded value of the current attribute from the cloud variable. If the function is used again, we will get the next attribute decoded. In our case, it is the word cat. Okay, let's get back to the main program. We have now successfully defined the key functions and we now just have to implement them. We can do this with two custom blocks. One for encoding the attributes and sending them to the cloud variable, and the other one for decoding the script from the cloud variable and displaying it on screen. Right, so we can create the first custom block and call it send cloud data, making sure to run without screen refresh. The following code should be quite straightforward and easy to understand. We first set encoded to blank, then encode mouse X, and then encode mouse Y. Following this, we set P1 to encoded. Okay, let's now make the block for decoding the attributes. We can call this pre-movement and run without screen refresh. First of all, we get the cloud data from the cloud variable p1. We then begin decoding of value. Now that the prerequisites are set up, we can actually decode those numbers. With the getNextValue block, the value variable will be set to the x position. We do need variables to store the x and y position of the cat, so we create a variable called xPos for all sprites and then a variable called yPos for all sprites. We first set xPos to value, and after repeating the previous function, set yPos to value. All we have to do now is change the initial code in the forever loop. We can throw out the set p1 and p2 blocks because we can now do everything with a single variable. We replace those lines of code with the sendCloudData function. For decoding, we put the pre-movement function before we move on to the coordinates. Remember, we created the xPos and yPos variables to store the coordinates of the sprite, so we go to x, xPos, and y, yPos. Great, that's pretty much all we have to do for encoding and decoding. If you test your program with the familiar 2-tab setup, you should notice a big improvement in the movement of the cat in the second project. This is fantastic, as from the next video, we can focus on the more fun parts of the project. This will include the automatic entry and exit for the players and the tic-tac-toe game mechanics itself. With that said, thanks for watching, and I will see you in part 3.